Hi, in this video we're going to take a look at the uniform distribution. So we've looked at a couple of probability, well at least one probability distribution, the binomial probability distribution, and that is a discrete probability distribution. So there were a set number of trials and we looked at probabilities that were discrete. So the outcomes would be 0, 1, 2, 3, 4, 5, distinct values for x. In a continuous probability distribution, the random variable can take on any number between two numbers. So let's take a look at this first example so that we can see the difference between a discrete probability distribution and one that's continuous. For New York City, weekday late afternoon subway travel from Times Square to the Mets Stadium, you could take the number 7 train that leaves Times Square every 5 minutes. Given the subway departure schedule and the arrival of a passenger, the waiting time x is between 0 and 5 minutes, as described by the uniform distribution. Note that the wait times can be any value between 0 and 5 minutes, so it is possible to have a wait time of 2.33457 minutes. Note also that all the different possible waiting times are equally likely, given the uniform distribution. So here is a graph of this uniform distribution. So the wait times start at 0 and go up to 5. And the area of any continuous probability distribution, the area under that curve is going to be always 1. So this total area is 1. And so usually you'll be at least given the range of x values. So this one was between 0 and 5. And then sometimes you might have to calculate the height of this rectangle. And the height of this particular rectangle, we know it's on here already, it's 0.2. But if you need to calculate that, then the way that you do that is that it's equal to 1 over the length of the x-axis. So for us, that's 1 over 5. 0 to 5 is 5 minutes, which gives us a height of 0.2. And so now, if you calculate the area of this, it's 0.2 times 5, right? So this height is 0.2 and this length is 5, which gives you an area of 1. So remember, for the uniform distribution, you should always have an area of 1, and the probabilities are also going to be areas, right? So that's why this area is 1, because that's the total probability, the probability of all different options. And so when you sum up all of the possible probabilities, remember you always need to get 1 for a probability distribution. So let's take a look at doing some calculations. The first one, find the probability that a randomly selected passenger has a waiting time greater than 2 minutes. So taking a look at our graph up here, and the uniform distribution is nice and easy because the graph is just a rectangle versus it being some curve that's curvy. It's just a straight line, horizontal line, so that makes it nice. And so we want to find the area from 2 to 5 of this rectangle. So again, we're calculating the area. We want the length times the height. To calculate the length, you take the big number minus the small number. So here that's going to be 5 minus 2 gives us 3. And then the height is going to always be 0.2 for this particular one. And so we get 0.6. So the probability that your wait time is going to be greater than 2 minutes is 0.6, or you have a 60% chance that you're going to wait longer than 2 minutes. Find the probability that a randomly selected passenger has a wait time less than 1.5 minutes. So less than 1.5 minutes. So here's 1.5, and we want less than that. So that's going to be the area of this red rectangle. The length of that So the bigger number is 1.5 minus 0, so we have 1.5 for our length. And the area is, again, length times height. So that's 1.5 times the height, which is always going to be 0.2 for this particular example. And 1.5 times 0.2 is 0.3. So the probability that you'll wait less than 1.5 minutes is 0.3, or another way to say that is you'll have a 30% chance that your wait time will be less than 1.5 minutes. In the last one here, find the probability that a randomly selected passenger has a waiting time between 1 and 4 minutes. So let's go back up to our graph. So here's 1 minute, and we want to go up to 4 minutes. And so we need to calculate the area of this blue rectangle now. First, let's calculate our length. So that's the big number minus the small number, so 4 minus 1, and we get 3. Our probability is the area, and that's length times height. Our length is 3, and the height, again, always is staying 0.2 for this particular example. And so that gives us 0.6. So the probability that you would have a wait time that's between 1 and 4 minutes is 0.6, or again, the other way you could say that is that you have a 60% chance of waiting between 1 and 4 minutes, would be another way that you could state that. So again, back up to this graph of this rectangle. So this one started at 0, but these do not have to start at 0. They could start at any number, so they could start at 5 and go up to 12 or something like that. And then again, the height is the length that you have across your x-axis. It's 1 over that length, and that's how you compute your height of the rectangle. So that's it for this video. If you have any questions, let me know, and I hope you're having a great day. Thanks.